Hello, this slide is showing what happens at the synapse, which is the very end of where a nerve meets a muscle or where a nerve might meet another nerve. So the axonal terminals of one axon meeting the dendrites of another nerve. So the first thing you need to understand is that gap there is called the synapse, and it is fluid filled. They never show you the fluid on the diagrams in the books and the websites. Makes it seem like there's air there. Should always remember there's always fluid surrounding all these structures as we move forward in the course. So there's fluids, a fluid-filled gap, and this is a what I call a flow chart. It's this happens, then this happens, then this happens, then this happens. There's several of those things in IB biology, and so as the nerve impulse comes down, there's channels for calcium that open, and there's an influx of calcium into the knob. And the study guide that I always love and talk about, don't even mention the calcium. It's a mistake they left out. This slide has it. And so calcium comes in, and there's evidently calcium binding proteins in the vesicles. I think they're still trying to figure out all that's going on there. So IB doesn't require, a lot of the details, just that calcium comes in and it does trigger the vesicles to move to the end and to release the neurotransmitters by exocytosis. There's several different kinds of neurotransmitters in the body, and the neurotransmitter then diffuses across the cleft and binds to chemically gated channels on the nerve or the muscle, and it opens and the sodium comes in and it depolarizes, and just like we've learned, creates another nerve impulse, or the muscle does its muscle thing. And so that is the flow chart. So one more time, the nerve impulse comes down, calcium channels open, calcium from the fluid go in into the knob, and it causes the vesicles that have the neurotransmitters to migrate to the end and bond with the membrane and release their contents into the synapse by exocytosis, and it migrates across, triggering the depolarization on the other structure, sometimes called the postsynaptic neuron. Right, you got the presynaptic and the postsynaptic, and then there's enzymes that degrade the transmitter and it's reabsorbed back into the vesicles to be reused again.